So we're in the Harvard Science Center, which is the crossroads of the Harvard campus. A lot of the science departments have their classrooms and offices in here. What's behind us here is the Mark I computer, which was an early electromechanical computer. So the Mark I computer is here at Harvard because Howard Hathaway Aiken, who was the person who conceived and designed the machine in collaboration with IBM engineers, was a Harvard professor of applied mathematics. And he wanted to relieve the labor of solving numerical equations by mechanical calculation that was done on pencil and paper. And what we have here is actually only a chunk of it. It was 51 feet long when it was all in one piece. It could do 3 additions per second. A multiplication took 6 seconds, and a division took 15 seconds. So this was a huge advance over doing things with pencil and paper, but it was slow work, and keeping the machine going all the time was a major feat of electromechanical engineering expertise. It was used for ballistics calculations, for calculating the trajectory of missiles. And it was also used for a little bit of the calculation in the Manhattan Project for determining the right parameters for the atomic bomb. So what you see here are paper tape drives. So the program was punched in paper tape and was on a loop. What you see there are registers that would correspond to the stored memory of the machine, which was only used for data. The program itself was fixed. These electric typewriters were used to print the output. These dials, which have 10 positions, are where you would insert the constant. So the program was fixed on paper tape, and if you had a constant, like you have in C code, you set some variable equal to a 47 at the beginning of your program, this is the equivalent here. You would dial in the number 47 on these, using these registers. The computational equivalent of this is much less than the smallest wristwatch computer that is now being produced.